Hey everybody, welcome to another stream on the ESP32 e-paper dev kit construction. We're making our way through this. Hopefully people are finding this helpful and interesting about all the steps that go into making something like this. And so what we're going to do today, this will be a brief stream, I think. I hope. I have finished, I'm going to say finished, the trace layout, and I just wanted to go over that and show some of the things that I did and I had to work with and mess around with and move around, as well as some of the things that I'm worried about. Again, if you've been watching or if you haven't been watching, I am not a professional PCB layout artist, and it is an art form. It feels like it's like a combination of a puzzle maker and an art. And so I've been working a ton on that. What you see here is probably about, I'm going to say 7 or 8 hours of layout work. Again, I don't think it would take somebody that is a pro at this that long to do it, but it took me that long, and I don't know if I'm going to run into any problems with the way that I've laid things out. That remains to be seen, but I'm getting very close to the point, and I'm very excited for this, to place an order with a fab and assembly house to get a couple of these back. You know, probably do an order of 5. I want to show all that, like the cost of that, and get those back in to begin testing them. And so that's where we're at in the process. But let me talk a little bit about where we landed with all of the trace work here. So the last video that I posted, I was just getting started with laying out all of the traces. And when I say laying out the traces, for those of you that don't understand that, we've got these parts everywhere, and we need to draw lines between them. So like if we zoom way in, we need to go from USB data negative to this, I believe this one's a diode or a capacitor, one or the other. We need to go from here to here. So we draw a trace to get there. And we have to do that for everything on the board. You can't cross traces over unless they're connected to the same net. And we have an extra dimension to this, which is the bottom of the board. We can punch through the board, which is what these little holes are. Those are called vias, and you'll see this red comes down here, punches through to the bottom of the board. It's connected through. It's called plated through hole. It's plated all the way through, so electrical connection goes from the top to the bottom. And then green is represents all of the traces on the bottom. So when you're looking, this is still a good example on this enable trace. It goes to the bottom of the board right here, and then it goes under. It looks like it connects to this capacitor right here, but it really doesn't. It goes underneath of it, and it comes all the way down here, and then it pops back up over here and finishes its top side trace to the enable net over here. And so it's just a game of connecting everything and positioning everything so that you can get all of the traces there. Again, you can't cross them. You have to do things like go to one side, move a little bit, come back up on the other side, and you want to do this with as minimal tracing as possible. Now, some of the things that I am concerned about with the layout, although I don't know if I'm rightfully concerned, we'll find out, is you're supposed to impedance match USB lines. And what that means is you want them laid out in a certain way and spaced a certain way and made of a certain thickness of copper and everything so that they have a certain resistance, a differential resistance. And for USB, that's supposed to be 90 ohms, I believe. Now, that's not always possible because of cramped conditions on the board or other things, and so you do the best that you can. And the data sheets, as far as that I've seen for the FTDI chip, which is this big guy up here, seem to indicate that if the run is short enough, you're okay if you're not impedance matched on that. And so there's a couple of things I'm worried about. First of all, that these traces aren't set up for that differential impedance, but also I had to cross them over. And so I think I talked about this before in a previous video. The positive here from the USB has to get to the far side pin on the FTDI. And so it'd be nice if on the FTDI, these two pins, 8 and 9, if these were switched, this would have been a lot nicer. But I did some trickery here, which is I came through, I'm coming through these are, I believe, 2 diodes and a diode on each one and a capacitor on each USB data line. I come through and I'm going underneath of this resistor. I chose these resistors to be a bigger package size so I could bring the line underneath this one, which gives me my crossover. That's how I'm crossing them. And then they come up to the FTDI chip, and the FTDI chip turns them into this TX and RX signals that go over to my ESP32 module. So I'm a little concerned about if this will have any effect on the USB data integrity. And so the only way to know that is to either be an expert or pay an expert, or to just get some in, test it, and see where we land. That's a way that I learn, is by trying this stuff out and figuring out as we go. Now, another thing that we did, and we talked about in a previous stream, is that I moved all the power circuitry on my existing PCB that I have now that has the Particle P1 module. All my power circuitry is up here in the corner. Well, on this one, I moved most of it down here because this is where the 3.3 volt line is on the ESP32. On the Particle, it was up here, so it made more sense to do the power stuff in the top corner. But since we need 3.3 volts down here, I figured it would be best to generate it down here as close as possible. We had all this room anyway, so might as well use it. What problem I ran into there, however, is that I didn't have quite enough space to fit all of the power circuitry there. And so I actually end up taking the USB 5 volts up, like behind the connector and up here. That's what this F1 pad 2 is. And this is actually exactly how it works on my existing PCB, because this is where, again, all the power circuitry is. I get the 5 volts from USB up here, and then I take it all the way down with this 5 volt line that you see right here, all the way down here to the PMIC and the linear voltage regulator. And so I'm not worried that the 5 volts traveling that far. I just don't love it, but I couldn't quite puzzle a way together to do it better than that. And so that's where we ended up on that. And one thing that I also did is, you'll see that I kind of came out and around and did a very not direct route to where I needed to get it down here. And that's because I think it's overkill, but I wasn't sure how running 5 volts perpendicular underneath of the USB lines could interfere. And so back from my engineering days, and again, I don't know if this is actually a thing, but the right hand rule, if you've ever done engineering, if your thumb is the direction of current, your fingers will tell you the magnetic field that is created around that. And so what would essentially be happening is, if I ran the 5 volts right under here, and again, it may be such low current that it doesn't even matter, and I'm just using theory in my head to freak myself out. If I ran that directly perpendicular underneath here, I was worried that I would induce some interference left to right here that could mess with the USB lines. And the only time the 5 volt line here is energized is when the USB cable is plugged into power. It doesn't always have to be plugged into a data connection, but if it's plugged in to a data connection, it's going to have that power. It's going to be charging the battery. A decent amount of current is going to be running on this trace. And so just to avoid any problems with that, I ran it around. The other reason and the thought behind that, again, whether it's necessary or not, is that if it does cause some issue, it's going to be a very subtle, non-obvious thing. Like I would imagine, I'm picturing in my mind things like random drop packets on the USB protocol, and just very weird behavior that's hard to dig into and figure out. And so just to avoid it altogether, I ran it around. It turns out that I can do that just fine without losing enough room to run other traces. I got everything else traced in, and so I think we'll be okay there. But again, we'll see when we get the boards in. Now, if you remember also from last time, the what's it called? Tag Connect debug connector was down here in the lower left-hand corner. I didn't like it down there because of how awkward it is to plug into when the screen is connected and it's installed in the case. And so I wanted to put it somewhere over here. I didn't have any room. It turns out after all was said and done, I had a whole bunch of space right here in the middle. And so I dropped it right in the middle. However, if you're paying really close attention, it's bigger than the old one. The old one only had 6 pins right here. This one has 10 pins, and that's because I need the extra I need to use JTAG debugging on the ESP32 and not what's called SWD debugging. And I found this out. I was looking up, this is the JTAG documentation. And where was it? Right here. This page lists SWD compatible adapters as well. Take note, the ESP32 does not support SWD. And so we have to use full JTAG to debug this and create a debug connection. The Particle P1 supported SWD debugging, which is what I have an adapter for, an ST-Link knockoff that works fine. And so, but for the ESP32, it needs to be the actual JTAG lines. And so I wanted to have that ability. It's not a hard requirement. We can get around not having that, but without it, we can't really debug, like step-by-step debug. And that's a feature that I really wanted this to have, because when you're developing a product, print lines work okay, but you could be more productive if you can actually spin up a legit debug session and start debugging your code. And so we went with the bigger Tag Connect. And again, you don't have to use Tag Connect. And it's funny, they say it takes up very little space on the board. This does not look like a little bit of space. It's kind of big. And I think we could get by with a smaller connector. But the positive is there is no part. This is it. There's no physical surface mount component that we have to solder to this. It's all in the cable, a very expensive cable, but it's just copper pads on the board that we can connect a cable to, which I'll show you in a different stream when we get there. But so this is now smack dab in the middle. I originally had said I was going to try and fit the buttons over here, ended up not having room, and so it turns out I also stuffed them in here as well, these two buttons, so that I can have a mode and, not a mode, what are they called? IO and enable buttons for the ESP32 for boot modes and things like that. Those are not required. You can control everything through USB and through the FTDI chip. You've got this DTR and RTS, which go into some gate logic and pop out to the enable and the IO pins. And so you can hands-free essentially push these buttons with USB, if that makes sense. And I'll show all that when we get to the point where we actually have some hardware that we can start testing with. And so that's pretty much all the change. Oh, I'm forgetting one of the biggest changes, which as far as being a dev board, I wanted to add a header to break out some more of the pins. Like, it's cool to have the e-paper thing and have all that ready to go in a nice enclosure that you can use. But in the event that you want to break out pins for whatever project you're working on, I wanted to have the option to have a header up here. And so this hardware as is will work fine for my product. As a dev kit, I can just populate this extra header and the buttons. Like, I wouldn't put the buttons on my product either, but the same printed circuit board layout will work for both a dev kit and what I need for it to do as an actual product that I'm shipping. And so that is the other big addition that I don't believe was here last time. It took some doing to run some traces up there, but we managed to get there. The only other very subtle thing is I slid a bunch of these capacitors over here for the display. Getting around here was a little bit dicey. We had to go with smaller traces, and hopefully that's all okay. So all things that we will test when we get hardware in hand. And so at this point, I have satisfied all of the non-ground net connections and all the rat's nests left. If you remember when we first started, these white lines were everywhere. These white lines, like right here and this ground to ground, they were everywhere. Now, the only ones left are connections to ground. And the way we will fill those is with a ground pour on top and bottom. I don't know a lot about what values to use for that, but doing the ground pour is super, super simple. You just come over here to the side, add fill zone, and then you just, it's for ground. You select, it's the ground, you say okay, and then you just literally draw. I'll show you how this works, and then I'll tweak it not on the stream because I think it's going to take me a while. You don't have to be perfect about this. You can see I'm just kind of rough outlining it because it will know where the board edges are, and it'll even do a setback, which I'll show you in a second. Like, I'll purposely draw it not perfect. And self-intersecting are not allowed like that. Okay, come on, just connect. Oh, can we just, there we go. Okay. So you can see it actually detects the board edge and then sets it in a little bit. And so now if we come back up, if you remember, there was a rat's nest line over here, this ground to ground. It does that. It does thermal relief. It gives you a distance around, and then that's it. So this is all ground. All the red you see is ground, but you can see we still have some unconnected nets. And so we need to get like this ground right here. We need to get connected, I guess, over to here and into the ground plane here. Like there's still some connections that I'll have to figure out, but drawing the fill zone itself is not very difficult. And so I'm going to play with that until I get the fill zone ground on top and bottom. And I think at that point, we're going to be ready to do part selection. I want to show that. It's like, it's not time to ship it off yet. I could ship it off to fab, but I couldn't ship it off to assembly. And so we'll go through part selection, how I get the list of parts and dump them out of KiCad and build up a bill of materials. That's something that I struggled with a bunch with my original product. I was keeping it in a Google Sheet stock, which works fine, but I think there's some stuff with KiCad that I'm really excited about messing with that should help with component lists and keeping it in source control. I love the idea of having all this stuff in a Git repo so that I can version it. And so I know I sent version 1.3 to the fab and assembly house, and this was the list of parts, and I can always recall that. I don't need to look at like Google Sheets history or pay like $100 a month for a bomb software for something simple like this. And so we've got all our traces. We just need to get the ground connections done, and then we'll move on to component selection. And we're getting close to sending off an order to the fab and assembly house. Right now, I don't know what kind of wait times there'd be for that with everything that's going on with COVID-19. I hope everybody out there is staying safe and healthy and learning a little bit as we go through the process here. That's all we're going to do for now. I'm going to lay the ground planes. If I learn anything interesting from that, I'll show it. But that's where we're at so far. Just step by step, we're going to get there, get some hardware. I really want to get some hardware in hand. It'd be really awesome to have like a thing that when I plug it in, hopefully it doesn't smoke out. Like hopefully we get some ESP32 booting, and we can start writing some firmware, which is much more my interest and things like that. So got to go through all these parts first to get that hardware so we can start programming it. So that's going to do it for the stream today. If you have any questions, please on YouTube, stick them in the comments down below. Reach out. Love hearing from people. So otherwise, we'll catch you next time.